Welcome back, ladies and gentlemen. Today we're going to take care of section 5.5, the first bit anyways, just solving basic trigonometric equations. These are equations that have a trig function in them of some sort, and they'll get more complex as we go through it, but we're going to start with the very basics. If you're one of those people that think they can handle it, there's your homework for the next 2 days. I've split up one worksheet, giving you a problem set for each day, and each day you're submitting any number of problems from that worksheet. Here's our first question. Cosine of x is square root of 2 over 2. What does that mean to you? Well, it basically means they're asking what angle will give you a cosine value or has an x coordinate, if you're thinking about unit circle, of square root of 2 over 2. Right away you should say, well, that has multiple answers to it, and you're absolutely right. So if you pull out, say, a unit circle, there's actually two locations where there's an x coordinate of square root of 2 over 2, right there and right there, at pi over 4 and 7 pi over 4. And that's just on the unit circle. Remember that the unit circle is just covering the angles between 0 and 2 pi. If we keep going more and more times around the unit circle, we're going to get more and more answers every time we clock by, every time we rotate by this location and this location. So maybe we look at it visually. We graph a cosine, we graph the square root of 2 over 2 as a horizontal line just to see where it intersects. That looks like that square root of 2 is about 0.707 as a decimal, so it's plotted right there. You go find all the intersections, and you'll notice it's kind of the same problem, is that we have basically an infinite number of intersections. We're sure on these two, these are on the unit circle. We could do some more work to figure out what those two are, but the real question is how long and how far does that go for, and what are we responsible for reporting when we do a problem like this? Well, we got to think, are we just responsible for the angles on the unit circle? Are we responsible for all of the angles ever? So are we going to have to write like one of those sentences that says like it's pi over 4 plus every 2 pi thereafter, or something like that? Or are we going to totally restrict our line of sight into the same sort of restrictions that we did with inverse trig? Are we only allowed to give out angles between, for a cosine between 0 and pi, or sine between negative pi over 2 and positive pi over 2, that sort of thing. So there's a lot of flexibility, or there's a lot of ambiguity to this question. Well, the long and short of it is that they're going to have to give you a restriction of some sort. The most common way to do that is to say, you're only going to find the solutions on the domain of 0 to 2 pi. They could change that domain. Sometimes it's 0 to pi, sometimes it's 0 to 4 pi. And you do have to pay attention to the endpoints, whether they're included or not included, like in this case. Or sometimes they will say, you have to tell me a pattern that will generate all the solutions. That is, every single pink dot that's going to hit this line as it traverses along the x-axis forever towards x to infinity. So you have to come up with a rule that will generate all of the possible solutions. I think in this course, the only thing that we're going to be asked to do is to find solutions on this domain, 0 to 2 pi. Always check this just to make sure, but I think all we're responsible for is being able to find the solutions on 0 to 2 pi. In other words, you're only responsible for finding the angles within the unit circle minus one specific angle of 2 pi. So if we wanted to answer this question, they'd have to provide us with a little bit more information. Do they want all these solutions, or do they just want a limited number of solutions based on this interval? And if they give us this interval, then we would only be responsible for identifying the angles that are on the unit circle or in this region of the graph, and our final answer would just be pi over 4 and 7 pi over 4. As we move on to other problems, though, just keep an eye on this number or this restriction, or even if there is a restriction, because it may change, or it just they may change whether they want a limited number of solutions or all solutions. Let's take a look at a couple problems. Here we go. Here's the first two. These are the simplistic form of these equations, and they're a lot like those inverse trig questions. What angle will give you either positive or negative square root of 3 over 2, or what angle will give you a sine value of 0? So this one, again, it's really good to have a unit circle memorized or out, and we want to go find all the places where the sine value is square root of 3 over 2 or negative square root of 3 over 2. You'll notice that that occurs in 4 different locations, and we just want to run by all 4 of those locations. Are all 4 of those locations within this interval? They are, so we would just simply list them all out. There's 4 answers to that question. Basically, same thing over here. What angles have a y coordinate of 0? Right there and right there. That would be 0, pi, and 2 pi. and we list all of those answers. But check out this. You'll notice 2 pi is not listed. Well, why is 2 pi not listed? If you take a look at this interval just closely, you'll notice that this is a round bracket, meaning that it's excluding the value of exactly 2 pi. We're only listing 0 to 2 pi, so we're only going to get those 2 solutions and not include 2 pi. If we step up a layer in complexity, the problems start looking more and more like this, okay? All I did was add a 2, but it changes the way that we do the problem. And now that we've done some verifying trig identities, I think we should be comfortable with the idea that this is a sine times a sine that's getting 1/4, or the sine value of an angle times the sine value of an angle, or in other words, the sine of an angle squared is 1/4. Well, if I can't really answer that question off the top of my head, and certainly not on a unit circle, so let's get it down to basics. Let's just make this equation look so that it just says sine of x equals something without anything around the trig function whatsoever. So what we're going to do is we're going to take the square root of both sides of the equation. Now, every time you take a square root, remember that you're accounting for both a positive and a negative solution. So you see a little plus minus pop up here, and then go find those locations on the unit circle, and you'll find 4 of them, and simply list them out. That's all we do. Why don't you go ahead and pause the video right here and try this one for yourself. The only difference between this problem and the previous 2 or 3 problems is that there's just more and more layers of complexity that we have to unwrap before we get at the heart of the solution. So same strategy, basically. We want to get this trig function stripped down so that it's not being squared, there's not a 5 next to it, and there's not an 8 next to it. All we have to do is unwrap those layers in the correct order of operations. So we're going to get rid of the subtract 8, then we're going to divide by 5, then we're going to take a square root. So we're saving the square for last. That's a common mistake. You want to save this for last. So first step, add 8 to both sides, then divide by 5. Take a square root. When we take a square root, we always throw a plus minus in front of there. Now, where does cosine equal either positive or negative 1? That happens on the left and the right hand side of the unit circle. So we would include 0, pi, and 2 pi, but remember we're excluding 2 pi because of the interval, so we just get 0 and pi. This next example is another one that I think you can just straight up take a shot at. Why don't you pause the video and give it a shot? Okay, you may notice this problem has 2 terms where there is a cosine squared. And you can picture that almost just like as if there was a term called 8x squared and 4x squared. And if that was true, basically what you'd want to do is you want to combine like terms. And these are like terms. They both have a cosine squared. So that's exactly what we're going to do as a first step. We're going to subtract a 4 cosine squared of x from both sides. And doing that subtraction, you'll get 4 cosine squared of x on one side, and this side will remain 0. From there, it looks a lot like the previous problem where we're going to add 3, divide by 4, and then take a square root. Remembering that every time we take a square root, we are also going to put a plus minus in front of everything. And then find those locations around the unit circle. This time there are 4 of them, x coordinates of positive square root of 3 over 2 or negative square root of 3 over 2. The same solution set that we had before, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Again, here's your assignment. I'll see you next time.